Continuing with discussing the security models, the remaining models that should be considered are, the Clark-Wilson model, the Brewer and Nash model, the Godwin-Meseger model, the Sutherland model, and the Graham-Denning model. The Clark-Wilson model is similar to the Biba model, but with a focus on commercial applications. The model's purpose is to protect the integrity of data, and it achieves this by defining data items, and limiting the modification of these items to a specific set of programs. The model applies a three-part relationship between subjects, objects, and transactions, known as the access control triple. The subjects are not allowed to access the objects directly, but rather the objects are accessed through the programs that perform the transactions. So to protect integrity, the Clark-Wilson establishes well-formed transactions and applies a segregation of duties principle. Each program has a limited set of transactions that it can perform on an object, which limits the subject's capabilities consequently. The subject has access to a specific set of objects, and can perform a specific set of transactions on them. The next model is called the Brewer and Nash model, also known as the Chinese wall. The concept behind this model is to create a dynamic system, where access controls change based on the user's activities. However, the access controls should always maintain the concept of conflict of interest, where the activities that a user can perform do not conflict with the new activities that would be granted to him. The model works by creating security domains that are potentially in conflict with each other, and any subject that has an access to one of the domains can't be granted access to another domain that would create a conflict. In other words, this model ensures the data isolation within each security domain. The dynamic nature along with the isolation concept ensures the security of the data. Next, is the Godwin-Meseger model, which is also concerned with the protection of the data integrity. This model dictates that subjects can perform predetermined actions on a set of predetermined objects, and subjects with the same capabilities are grouped into a domain that is not allowed to interfere with other domains. The Sutherland model focuses on data integrity as well, but instead of defining access domains, a specific set of system states is allowed, and the system will only be in one of these states at any given point in time. The last security model, which is the Graham-Denning model, is focused on securing the creation and deletion of subjects and objects. This is ensured through a set of 8 rules, that secure the creation and deletion of subjects and objects, and controls the access rights.